Okay, with this video I want to begin a series of discussions about some new derivatives that we haven't dealt with in the past, and those are derivatives of exponential, logarithmic, and inverse trigonometric functions. And let's begin with the very simple e to the x. The first thing that you have to know about differentiating or the derivative of this type of function is that you cannot use the power rule with this. Assume we had a function that looked like g of x is equal to 3x squared. Well, we know the derivative of that, g prime of x, is equal to 6x by the power rule. If you notice the difference between these two functions, it is that the exponent is a constant in the polynomial one, 3x squared, but the exponent is a variable in the exponential function. So this is a major difference here. And when you see the variable in the exponent, you cannot use the power rule. So please do not try to make this become x times e to the x minus 1. That is not applicable for exponential functions. So instead we need to find a new type of function or a new type of derivative for this function. And for this we go back to our basic definition of derivatives. Recall that by the limit definition of a derivative, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And in this case, f of x is equal to e to the x. And so f of x plus h, we just replace x with whatever's in the parentheses and we get e to the x plus h. And so we're left with limit as h approaches 0 of e to the x plus h minus e to the x over h. We should note that the e to the x plus h, one of our properties of exponents, tells us that when you multiply two numbers with the same base, you add their exponents. So whenever you see two exponents added together, that should remind you of the fact that originally there were two numbers with the same base multiplied times each other. In this case the base is h and the two exponents are x and h. And from this we get limit as h approaches 0 of e to the x times e to the h minus e to the x over h. And you might be able to see that we can factor out an e to the x here, and we're left with an expression such as limit as h approaches 0 of e to the x times quantity e to the h minus 1 over h. A long time ago, and we used our calculator to evaluate a limit that was e to the x minus 1 over x, limit as x approaches 0. Well, we don't quite have that here, but we do have e to the h minus 1 over h, limit as h goes to 0. So the variable doesn't really matter. What we have is the same idea. We're going to go to our graphing calculator right now and see how we would recall how we found this in the past. So we go to y equals. We're going to hit second. Down here the ln key has an e to the x, and we want e to the x minus 1, but we need parentheses around that, and so and second, insert, add a left parenthesis there, and we go back to now divide that whole expression by x, divided by x, and recall that we want the limit of that as x approaches 0. So what I'm going to do is go to table set and set auto ask on, and then go to the table and I enter some values as x approaches 0 from the left. I have negative 0.1, negative 0.01, negative 0.001, negative 0.0001, etc. And I'm approaching 1 from the left. We need to try this from the right. And when we do, we see that we're also approaching 1. So the limit of that expression is just 1. And we'll go back to our work on the previous screen. Well, since we know that the limit as h approaches 0 of e to the h minus 1 over h is 1, then we're left with the fact that that limit is just e to the x. And this is our first